So we're now studying this idea of maximum and minimum values when we're talking about quadratics, or to the second power, and are, as some of you call it, parabolas. So when we look at this, the main thing we care about for the maximum and the minimum value is this a going to be a positive number or a negative number? If the a is positive, then it's going to smile. If the a is negative, it will frown. And so in this case, the a would be negative because it's going down. It's really that simple. It's that easy. And so you don't really have to do much work to identify something as a maximum or minimum value in itself. So today what we're going to look at is how to first identify it, and then secondly, what is that maximum or minimum value? Where on the y-axis would that be? And we'll talk about how to find that today. So tell whether the function, and it gives you a parabola, has a minimum value or a maximum value. That's really easy to do. Again, the a is negative. So if the a is negative, we know it's frowning. So when it's frowning, though, it has a maximum value. Going back to the page you're just looking at, when it's frowning, the highest point, the maximum point, is at the top, right? So when it's a negative, when the a is negative, you have a maximum value. And remember the word maximum, maybe you could think of it like a speed limit. You know, the maximum you can go is 55. You don't want to go higher than that. You can go lower than that. A minimum would maybe be thought of as the minimum betting wager. You know, you must at least bet this amount, but you can bet more than that amount, but not less. So, or maybe you can think of it as when you're going to Disneyland. You know, the maximum height is 5 feet, and they do that because they don't want very tall people to go on little kids' rides, and so they have a maximum height, but they also have minimum heights. The minimum height you have to be to go on a ride is 5 feet because it goes too fast, so you can be higher than that, but you can't be lower. So maximum and minimum. Okay, so this is instantly identified because the a is negative that there's going to be a maximum height. Okay, and then so that's a pretty simple concept, right? There's not a lot to that. But then how do we find that value? How do we find out what that maximum height actually is? Well, we can do it by first finding the x value, by finding the axis of symmetry. And the formula for that is that x equals a negative b over 2a. So let's go back up to the quadratic and we'll label these. The coefficients or the numbers are a, b, and c. So it'll be a negative b, but the b is a negative 24, so it's going to be a negative 24 over 2, and the a is a negative 4. Okay, some of you like to simplify at this point, but I'm just going to work it all out right now. So a negative times a negative is a positive, and then 2 times a negative 4 is a negative 8. And then 24 divided by a negative 8 would be a negative 3 because 8 goes into 24 3 times. Okay, so we found the x value of the axis of symmetry, but also what's called the x value of the vertex, which is a negative 3. But we want to know not what divides it in half, the parabola. We want to know how high it is. So we don't want to know where it's at on the x-axis. We want to know where it's at on the, not the x-axis, but the y-axis. How high did this go? So in order to find out, we substitute the value for x, which again is of the vertex, which again is the axis of symmetry, into the quadratic to find out what the y would be. How high is it? So let's go ahead and do that. So all this working the reading has been the x, right? Now let's go ahead and find the y. So I'm going to take the same equation here. F of x equals negative 4x squared minus 24 times x minus 19. But in place of the x, I'm going to substitute in this new value we found for x, which is a -3. So everywhere where there was an x, there's now a -3. And we do the order of operations. Back to the very beginnings of algebra. So we square before we multiply. So that would be a -4. -3 times a -3 is a 9. Bring everything else down. And we multiply before we add or subtract. -36. A negative times a negative is a positive 72. And bring down the -19. And then when you're adding and subtracting, you should always do the one more to the left first. So -36 plus 72 would be 36 minus 19. 36 minus 19 will be the right answer. Give you a second to go ahead and find that. 17. So how high did this parabola go? 17 is the height of this parabola. So the answer for the maximum value would be y equals 17, or in this case we didn't use a y, we used a f of x, didn't we? So f of x equals 17. Good. Good. Okay, so we did the first one. We did an example like this. But I want to do an application problem. A lot of people, when they think of parabolas, they think of bridges or roller coasters or anything that has an arc on it, right? And so I wanted to do a real life problem with a bridge, okay? So it says the suspension cables between two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by, and it gives you this quadratic here, where x and y are measured in feet. What is the height of the cable above the water? So, and at its lowest point. What's the height of the cable at its lowest point? Now it's frowning. So if it's frowning, we're actually looking for a minimum point. You know the A is negative, and there's a minimum point when it frowns. What is the height above the water of this minimum point? Now some of you are tempted to count here. Just count what that would be. And maybe that's a good way to check yourself. But I'm going to use the formula. Now, and admittedly too, that it becomes a lot easier to use like Desmos.com, just get the answer, you know, type in the quadratic equation and then it just graphs it for you. But where's the fun of that? So x equals a negative b over 2a, right? Let's fix that real quick. And so what is the a, the b, and the c of this quadratic? Well, the a would be this first number. That's this first coefficient. The b would be the second, and the c would be the third. It's in descending order. So x equals a negative b, a negative 0.37 over 2 times the a, 0.000098. Okay, so this is actually where I do get a calculator. I don't know. It's just easier. So at this point, when you multiply this by 2, and then you divide this 0.37 negative by that number, you end up with approximately a 1,888. Okay, so now we have to substitute this 1,888 for the x value to find the height. So let's do that. We'd say y equals 0.000098, but instead of an x, we'll put 1,888 squared minus 0.37, but instead of an x, we're going to put 1,888 plus, what's the last number we added? Oh, 552. So when you square first and then multiply and then subtract, the answer ends up being around 203 feet. Okay, I want you guys to try one. Let's break it down step by step. Let's do number 7. Okay, so we're going to use the formula first of all. We're finding the axis of symmetry. We're going to label these, and then we're going to say what it would equal, right? So x equals a negative 8 over 2 times 8, which is just 16. And then 8 over 16 would be the same thing as a half. You found the axis of symmetry, but you still didn't find the height, the minimum maximum value. Oh, by the way, if it's positive, it's going to be smiling. So is that going to be a minimum or maximum value? Well, that would be a minimum, right? Because it's down at the furthest point in the parabola. So we found the x value, right? But we still need to find the y value. And we do that by substituting this into the original equation. So g of half equals 8 times half squared. I'm just substituting the half in place of the x. Minus 8 times half plus 6. We square first, right? So I'll just go down here a little bit. Give myself some more room. G of half, we're inputting a half, equals 8 times 1 over 4. You square 1, you get a 1. You square 2, you get a 4. Minus 8 times half plus 6. Then we multiply. How do we multiply a fraction with a whole number? Well, there's a couple ways. I like to just multiply and then divide. 8 times 1 is 8 divided by 4. Minus 8 times 1 is 8 divided by 2 plus 6. Now, in order to, when we add and subtract, we do the ones more to the left first. But in order to add these together or subtract these, you'd have to have a common denominator. There's 2 ways you can go about it. You can either divide, there's so many ways actually. You could divide this side by 2, and you would have a common 2. You can multiply this side by 2, we'd have a common 4. What do I want to do? Let's just keep the numbers smaller. I'll simplify this side by dividing, or you could divide both of them by 2. Let's do that. Let's divide this side by a 4. 4 goes into 8 2 times, 4 goes into itself 1. So it's just a 2. 2 goes into 8 4 times, 2 goes into itself 1 times, just a 4. Makes it pretty simple. So 2 minus 1 plus 6. 2 minus 4, if we do the left one first, is a negative 2 plus 6. And the right answer would be 4. So the answer would be a half, and the whole answer we're looking for, what is the maximum or minimum point? Well, it would be a 4. The minimum point would be a 4 of this. Okay, I was going to do one more problem because I think a lot of people think of it as roller coasters or bridges, but they don't always think about it in motion. But anytime you shoot a basketball or throw a football or a water balloon, as in this problem, you're doing a parabola. You're doing a quadratic of this form that we've been doing the whole time. And so I was going to do a problem like that just to show you an example, but I'm looking at how long this video is. So I think I'll stop it here, but just know it's the same thing as a bridge. It's the same concept we just did. If you're into throwing projectiles, it uses the same math. Okay, thank you.